So in the hands-on section for function prototypes, we'll look at two examples today. The first one is the one of the square function. So this over here is, of course, the function prototype ended by a semicolon, just like other statements. And we have the main function over here with a for loop in which x runs from 1 to 10, incremented by 1 every time, and the value of x is passed to the square function defined down here on line 14, and the return value from square is printed out followed by a space. And at the end we have one call to the puts function in order to insert a new line, a blank line, after the output produced in the for loop. Remember, all those numbers will be printed out on a single line. And as for the square function itself, this is it. It takes an integer which it receives as integer y as a parameter, which is multiplied by itself, and the result of y square is the return value of square. So let me run this very quickly and let me run it once just like this, and you can see the output. The squares of the integers from 1 through 10 are 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. Now, to demonstrate, the thing that I want to demonstrate now is how control is passed from one function to another. So over here, when we call square, our custom function, how we jump from this point in the program to this point in the program. And for that, I'm going to add a breakpoint over here, and I'm going to now run my program, and I'm going to step through it like we have a number of times before. So we have nothing on the console window, of course. Down here we have the value of x, right now not even initialized. I'm going to step through it with F10. X takes on the value 1, and now in the printf statement, show you this. When I hit F10, I do not go into the square function. For that, I have to do something else. Let me continue for a second. F10, I'm back at the for statement. X is going to be incremented now. X will take on the value 2, which I can see down here in the watch window. There you go. X is now 2. Now, instead of simply pressing F10 now, what I want to do is I want to see what's happening in more detail. So just now, square was called, and the return value was simply put in here, and we saw that being printed out to the console window. But I want to follow into the square function itself. And for that, instead of pressing F10, I'm going to press the F11 key. And you can see now, instead of just running over that one line of that one printf statement, I'm going to go into the detail. F11 steps into a function. So in this case, before the printf statement itself is executed, the square function first has to be evaluated, which requires me to step into, if I want to go into a function and see how things how code executes inside a function. So now I'm on line 14. I'm inside the function call of square. Now the value of, and look at the watch window over here, x has disappeared. X exists only in the main function. X does not exist inside the function square. Inside the function square, I have integer variable y, which I can see over here now. And y, the value of y that was passed over here in this call to square, that value was 2. Now let me continue running. I'm going to hit F10, and I have only one line of code over here. This should now return 2 times 2, 4. I'm going to hit F10 again, and again, and I'm back. And you can see now here, square, the function square, down here in the watch window, square returned 4. So in the watch window, I can even see the return values from different functions if I step into them using the F11 key. So the value computed by square is 4, as it should be. And now, see, the 4 hasn't been printed to the screen yet. For that, I'm going to hit the F10 key again. It will execute the printf statement, and there you see 4 on the console window. And I can keep stepping, go back up to the for statement, to the printf statement, x, the value of x is now equal to 3, and just one more time, let me step into the square function. I hit the F11 key for that. I go into the square function, y is equal to 3, I hit F10, 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 and look again over here, square returned 9. 3 times 3 is 9, right? So this is as it should be. I'm gonna hit, so nothing printed to the console window yet. Going to hit F10 again, and there you go, see the 9 on the output. So let's say at some point I'm done stepping through my program, I can remove the breakpoint, just hit F5 again, and that will complete the running of the program. I don't have to, just because I started stepping through a program doesn't mean I have to continuously do that. So I can end that prematurely, like I just did now. So I hope this clarifies how calls to functions work. And now let me go to our second example. For that, recent projects, I already wrote this one for you. This is the one where we had the maximum function, and there's no loop in this one, so I'm just going to run this once for you. And so execute with F5, enter 3 integers. I'm going to enter, let's say, 10, 29, and 5. Hit enter. Maximum is 29, of course. And let's set a breakpoint over here, and let's step through this just to see how control passes from the main function to the maximum function. So F10, enter 3 integers. Now at the scanf function, execute the scanf function, and let me enter 3 numbers over here, 12, 55, and let's say 10. I hit enter. We passed the scanf function now, and now again I have the same thing happening. I have a call to the maximum function. I want to see that happening, so I'm going to step into this with the F11 key. There you go. I'm in maximum. The values of x, y, and z, the local variables of function maximum, take on the values 12, 55, and 10, the values that number 1, number 2, and number 3 took, correct? So let me continue stepping. So I just defined integer variable max, and I am going to initialize it with a value of x. There you go. Max is now equal to 12, the value of x. And I continue to step. So if y is greater than max and y is 55, so 55 is greater than the value of max, which is 12. So I'm going to go into the if block. I'm going to set the value of max equal to y. See that here, max is now equal to 55. Step out, and Z is not greater than max, so we stepped over that if condition, and we're now here at the point where we return the value of max, which is 55, which happens to be the largest of x, y, and z. So step and step. And you can see again here, maximum returned 55 in the watch window. So maximum returned the value 55. So this evaluated return 55. That 55 will now be printed out by the printf statement. Step, and there you go. Maximum is 55. And we finish the program. So I just want to run this one more time and show you the importance of respecting data types. So let me put a breakpoint on this line and run this. Okay, so instead of entering 3 integers, I'm going to enter one floating point number and 2 integers. Now this is where I put the breakpoint, so by now number 1, number 2, and number 3 should have been read in. Check the values of number 1 is read as 3, but number 2 and number 3 are nonsense because the 0.5 that I typed in for the first number, which was supposed to be an integer, is causing problems and is not letting us read in the values of number 2 and number 3. Clearly, out of the 3 numbers that I put in, 55, the last one is the largest one. Let's see what happens if I continue running this. And the output is maximum is 3, which is obviously wrong, or at least not what I intended. So you can see that clearly the answer is wrong. The maximum value is 55 as I entered it, but because I did not think of the proper data type over here, that's causing the maximum function, well, not to malfunction, but at least behave unpredictably. So that's why it's important to make sure you're using the right data type, especially when you're taking anytime you're taking user input.